So looking at the formula, the College Board stuff for random variables, I can see a greater emphasis on the geometric distribution than probably what we spent on it. And basically the main thing I'm basing that off of is that it is on the formula sheet where it used to not be on the formula sheet. And I'm seeing some problems on College Board. So the one thing I wanted to do is show you, let's see, miscellaneous videos. So these are some videos that I've done a while back. If you go to the geometric distribution, just to go through, it's 19 minutes, and you probably wouldn't need to spend the whole time on it. Maybe not the first 5 or so minutes. But it's just working through some geometric problems.
The geometric PDF.
Using first the formula, then the geometric PDF, then geometric CDF, and things like that, just to kind of regroup on all that. So it might be worthwhile to do that. And then the other thing that I want to make sure I say, because I didn't talk about these at all this year because it's never been on the formula sheet, and that's these two right here. So with the binomial distribution, we talked about the mean and the standard deviation. We used it several times. We would even, make when the binomial distribution was approximately normal, we would use this mean and standard deviation to then compute probabilities using the normal distribution. We never did these. Okay, so I mean that's pretty easy. It's two straightforward formulas, but I want to make sure you see that. So then, just a quick example. Remember, the geometric distribution is continually doing trials until you get your first success. So like this would be continually rolling a fair die until you get a 3. Okay, so that has a 1/6 chance every time. So the mean of that is 1 divided by p. So 1 divided by 1/6 would be 6. And that is the average number of times you would have to roll a fair die, until you get a 3. So on average, you would have to roll 6 times. Sometimes you would roll less than 6 times. It's possible that you roll a lot more than 6 times. Right? Theoretically, the upper bound on the geometric distribution is infinity. So you could keep rolling theoretically in a million times before you get a 3. So, but the average would be 6. And then the standard deviation is 1 minus p, which would be 5/6, which is what I call q. It will be the square root of q divided by p. So it would be essentially the square root of 5/6 divided by 1/6. No, it's not going to work out like I wanted it to. The square root of 5/6 divided by 1/6. And that would be the standard deviation, whatever that number is. And that is, on average, it takes 6 tries to get a success. This number would give you a typical difference from that average. So if you had to do something with those two numbers, that's what you would do. Today, I'm actually going to split Unit 4 up into 2 days. Today, you're going to do the first 2 multiple choice sections, Section A and Section B. Thursday, you'll do Section C and then the free response problems. Unit 4 is essentially, for College Board, is essentially our Unit 2 and Unit 3. So it's a lot of stuff, very important. So we're going to do it over 2 days. So I hope this helps. Spend a little bit of time looking at the geometric distribution. If you have any questions, just let me know. And I will talk to you guys soon.